My name is Amber Bullen, and my presentation is about wrist flexor and extensor muscle recruitment during different types of contraction. Motor units are groupings of muscle fibers controlled by a single motor neuron. The size principle states that smaller motor units are recruited before larger ones. More motor units are recruited when demand on the muscle increases. There are three types of contraction: concentric, isometric, and eccentric. Of these, eccentric produces the most force. However, we know that muscle force does not equate to the amount of activation of that muscle. So what we wanted to know was, with wrist flexors and extensors, which type of contraction sees greatest activation? We also wanted to know if there was differences between flexors and extensors. We hypothesized that percent MVC would be highest in eccentric conditions and that flexors would exhibit greater percent MVC than extensors in all conditions. EMG was used to determine activation of flexors and extensors in isometric, concentric, and eccentric conditions. Max voluntary contraction was determined by peak amplitude experienced during a resisted contraction, and this was used as a basis of comparison for the rest of our trials. The subjects sat with their arms relaxed, resting on a table and in 90 degrees of flexion. For isometric conditions, participants were asked to hold the 5 to 10 pound weight for 10 seconds level to the floor. For concentric conditions, participants started at max flexion for extensors and max extension for flexors and moved through to max range of motion in 5 seconds. For eccentric, it was just the opposite as far as starting and ending points, but they still moved through the motion in 5 seconds. Percent MVC was calculated for each condition, and the means and standard deviation were calculated. Looking at our graph here, flexors being yellow and extensors being blue, we found that the greatest percent MVC was shown to be with concentric contraction. Extensors showed a greater percent MVC in all conditions. So this shows that our results did not support our hypothesis, and there are a few explanations for that. Looking through the research, it is found that greater motor unit activation is necessary for concentric contraction. This is because passive structures provide much of the force production in eccentric contraction, leading to less motor unit recruitment needed. Additionally, a study by Lieber et al. Found that wrist extensors have less cross-sectional area than flexors, which suggests that they are less able to produce force. Bringing that back into terms of motor unit activation, this could mean that the smallest motor units of the extensors were not sufficient to handle the demand, so more motor units were recruited. Clinical relevance to our findings include the fact that injury to passive structures will likely have a great impact on ability for eccentric contraction. Additionally, damage to neurons leading to forearm motor units, like in stroke, depending on actual course of the damage, requires us to prescribe exercise creatively.